Good evening, guys. How are you? I hope you are doing good. As you know, the class has already been 17 minutes late. So, okay. So make sure the screen is visible to you and I'm audible to you. Very quick. Okay. Good evening. Good evening to everyone. Good evening, Divyanshu. So screen is visible to you and I'm audible to you. Okay. So here we are with the lecture number 9, gravitation. Okay. So what we are going to do today, we will recall some concept from the previous one, from the previous lecture that we have did. And then we will learn a very important thing today, which is the gravitational potential. We have already deal with the gravitational potential energy. It is the concept similar to the gravitational potential energy. Okay. Then we are going to learn about the relation between gravitational field, intensity, and potential. Okay. The gravitational field intensity is not a special thing. It is the gravitational acceleration, you can say. Okay. Then we are going to learn about the Earth satellites and weightlessness. So what is that we are going to do today? Okay, one by one. Now, the very first thing is recall. In recall part, we have done the Kepler's law in the previous lecture. So Kepler has formulated three laws, which is the law of area, law of orbit, and law of periods. Okay, I have told you several times that Kepler was not the responsible for numbering them. Okay, so any law you can put on any number. Okay, it is not like that you have to put law of orbit to the at position 1, or law of area as position number 2, or law of periods as position 3. No, it is not like that. Okay, you can put wherever you want, but we according to the convention, we have put law of orbit at first place, law of area second place, and law of period at third place. We are, for the student joining now, we are not studying in a detailed view. Okay, we are just revising this. What is the law of orbit? So law of orbit is said that each and every planet is revolving around the sun in a elliptical manner. Okay, in a elliptical path. So law of orbit is elliptical orbit. Elliptical orbit with sun at the one foci, situated at one foci. ठीक है. Law of areas, law of areas में the area swept by the line joining the center of sun to the center of planet, and the area swept by this line per unit time is a constant quantity. So dA by dt is L upon 2m, which is a constant quantity. So area swept by this line is equals to a constant quantity, which means you can say here, you can see, let me just change the screen. This is the ellipse. Here is the sun you have at one foci, and this planet is revolving around the sun, and this is the line joining the sun. Suppose this planet moves here. So the area swept by this is this shaded area. Now, this planet has moved from here to here. So this is the area swept by it. Okay. So you can say that the area swept by per unit time. Let's say here this area is A2. So A2 by T and A2 by delta T1, A, and this area is A1 by delta T1. 1 इसे कहेंगे, 2 इसे कहेंगे, delta T1. So these ratios are equal to each other. A2 by delta T2. Okay. So for that you can conclude one thing very important, that the speed, the linear speed of the planet is not constant. Why? Because when the planet is farthest to sun, which means at the aphelion position, it is at the farthest point from the sun, so it should have covered less area. But in order to maintain that constancy, area per unit time, this line has to move faster here so that it cover more area in less time. Okay. Suppose this planet has moved from here to here in 10 days. So for 10 days, this, because this area coverage is small here, because the planet is nearer to sun, so this line has to move at a faster rate so that it can cover the same area that the line cover here, because the time is same. Okay. So the velocity of this planet at aphelion position is less than the perihelion position. So at this, if the velocity here is v1 and velocity here is v2, so you can definitely say that v1 is greater than v2. सो सन के जब नियर होगा और कोई भी प्लेनेट, तो वहां से बहुत फास्ट मूव करेगा, एंड जब सबसे क्लोज होगा तो वहां से स्लोली मूव करेगा. ठीक है. दिस इज द लॉ ऑफ एरिया. नाउ द लॉ ऑफ पीरियड्स. Law of periods said that the period is a term which we use for a planet to complete one revolution around the sun. The time taken by any planet around the sun to complete one revolution is called the time period, or simply the period of that planet. So according to law of period of any planet is directly, square of it is directly proportional to the cube of semi-major axis of that elliptical path. Okay. This is the major axis. Major axis. This is minor axis in ellipse. Okay. And this is the center. These are the focus. F1, F2. Okay. This axis is major axis. So from center to this point, this is called the semi-major axis. Semi-major axis. Okay. From this point to this point, it is major axis, and just the half of it will become semi-major axis. If you inscribe a circle in this, so because circle is a subset of this ellipse, so this semi-major axis, in case of a circle equal to the radius of circle. Okay. So if the planet is revolving in a circular orbit, so you can take the semi-major axis as small r. Yeah, it is possible, because the satellite that will launch, most of the satellite will rotate about the earth in a circular orbit. So earth is the heavier mass object, and that is a lesser mass object. So it would follow the Kepler's law because there is a planetary motion is there. So in that case, you will say that t square is directly proportional to the radius cube, which is also satisfying the Kepler's law. Got it? Where a cube is the semi major axis. Okay. So these three laws we have studied in the previous chapter, in the previous lesson. Now we will proceed with the gravitational potential. So if I talk about mathematically, firstly I will give you an idea. What is this? Okay, law of periods explains once again. Okay, Patil, I am doing it here. So law of period is says that, just a second, law of period. The law of period tells us about that, just a second. Here is the sun and here is a planet. This is P, this is S. So this is revolving around the sun. This planet is revolving around the sun. So time taken by this planet to complete one revolution around the sun is called as period of that planet. So Kepler has said that the period square of a planet revolving around the sun or a heavier mass object is directly proportional to the cube of semi-major axis. Semi-major axis is from here to here. This, because this complete length is the major axis. So half of it will become semi-major axis. So this length would become semi-major axis. Okay, got it? So that is why this t square is directly proportional to a cube. If the time period by one planet is t1 is equals to k a1 cube, and time period for another planet is t2 square, k we have removed the proportionality sign, a2 cube, then if you take the ratio of it, t1 by t2 square is equals to a1 by a2 whole cube. So this is the law of periods. Now the part of this law of period, I have derived it by taking the circular orbit. And you can take the orbit to be circular just to assume that semi-major axis is equals to the radius of that circle. Okay. So I think now it's been clear to you, KMP Patil. Now it is clear to you, so that we will start our topic. Okay. So gravitational potential, firstly, I will tell you mathematically. Oh, no problem, yeah. I am here to resolve your doubt. It's my duty. So gravitational potential energy, if I talk about what is the gravitational potential energy. So gravitational potential energy is the energy required to bring a mass particle or point mass from infinity to a certain point. Okay? किसी भी point को infinity से means a very far distance. Let me take here an example. This is a mass. It has created its gravitational field, and there is a point mass present at infinity. So what we can say, the gravitational potential energy is the effort that we put to bring this mass particle m0 from infinity to the certain point in the gravitational field of another mass particle. Let's say at point A. So from infinity to A, whatever distances we have covered, the effort we put, the energy we put in that mass particle to bring it from infinity to a particular or specific point, is the energy is called the potential energy. But the condition here is that that particle must not be accelerated. So we would bring it very slowly. Okay, got it? The same thing is going for gravitational potential. This is a point mass. Okay, got it? So if there is another point mass particle m naught, I want to bring it from infinity to point A. So if the energy utilized here is U, so energy per unit mass of that particular point mass is called the potential of that point. Potential of point. Okay. From infinity to point A, whatever energy I have put to bring this m node to point A, let's just remove it. Whatever energy we have put to move this m node point mass from infinity to point A, and if I calculate the potential at A, it would be defined as the potential energy per unit mass. Okay. So potential energy per unit mass of that particle is defined as the potential at A. Okay. In very simple word, if I tell you, if there is a point A, there is a point B, and if here is a mass particle m naught, I have bring it from B to A. Okay. So the change in potential energy you will define here as UB, sorry, final minus initial. Okay. If you take this change of potential energy per unit mass, this will become the potential difference. Okay. This is nothing but the potential difference. ठीक है. इंडिविजुअली क्या पोटेंशियल है उस पार्टिकल का, पर यूनिट मास का मतलब क्या हुआ, we have divided it by mass itself. So individually, how much potential that point mass has carried with itself, that is the potential, gravitational potential. Like 2 kg of banana, सॉरी केजी में तो बनाना मेजर नहीं करते, लेट्स से ऑरेंज, 2 kg of orange gives you around, let's say, 100 gram of vitamin C. ठीक है. Now if I want to calculate the potential of this orange in terms of the vitamin C, so what can I do? The 2000 gram of it gives me 100 gram of vitamin C. So 1 gram will give me, I have divided with the whole mass of it, 100 by 2000. Or let's say 1000, 1 by 20, which means 0.05. 0.05 vitamin C per unit mass is provided by this orange. So a unit mass of this orange would able to provide 0.05 of vitamin C. Similarly, if the change in potential from B to A is 100 joule for this mass particle, and this particle has a weight of 2 kg, then if I divide it by 2 kg, this 100 joule, it would be 50 joule per kg, which means this mass particle has a 50 joule of energy carrying per unit of kilogram, per unit of mass. So that is the potential of it. Okay, got it? Mathematically, if I want to derive it, Mathematically, it is defined as the potential energy per unit mass. I have already told you when I was deriving the expression for potential energy that potential energy is not individually defined. You cannot we cannot tell the potential energy of a particular point. The only thing that we are able to do is the change in potential energy. Okay? So same goes with gravitational potential. So only the change of gravitational potential we are able to provide, not the specific potential. Until and unless we do not know the actual value of a potential from a point for a point. Okay? So from the definition, it is defined as the gravitational potential energy per unit mass. Okay, so we can say that change in potential delta V is equals to the change in kinetic potential energy per unit mass. ठीक है? The another definition of it will be it is defined as the, you know that this delta U is nothing but the negative of work done by conservative force FC dot dr, है ना? Or we can say negative of work done by conservative force. So we can define the potential from this definition also. So it is defined as the work done to bringing a unit mass. Mass mean per unit mass we are talking about. Unit mass from infinity to a specific point. ठीक है? In a given gravitational field. Without acceleration. ठीक है? So you can say that this delta V is equals to delta U by M, or you can say it minus of work done by conservative force per unit mass. So this is the actual definition of it, the mathematical definition. Got it? We can also say that this delta V, let's say it is a potential difference of VB minus VA, which we will define as UB minus UA by M. If we can consider UA to be 0, so potential of that point will also be 0. So VB we also have VB is equals to ub by, or we can say vb is equals to ub by, you can consider vb to be v and ub to be u, so it is in a specific value. V is equals to u by m. Got it? Now, in this, if anyone has any problem, can raise their hand or ask in the chat box. Okay, Patel. Now we are going to see what is the definition, what is the relation between gravitational field intensity and gravitational potential. Okay? So for that, we need a gravitational field. This is the gravitational field I have drawn with the air. It means कि gravity is acting in this direction. ठीक है? In the direction of air. And let's say the gravitational field intensity here we have defined as E. So E vector has a direction in this direction. Let's say we have a point A here. Okay. And this is point B. Got it? Now, the force on a point mass small m in this field. What is that? Very simple. Suppose this is our Earth. Earth has created its field acting radially downward, and there is a point mass. So by which force it will attract to it? It will attracting it. It is the gravitational acceleration. So you can say that F is equals to GMEM by R square. And you can say that GME over R square will become the gravitational acceleration. So force will be mass into the gravitational acceleration. So here the same concept we are going to use. Force in this field, because this field intensity is E and the point mass is small m. So we can say that force vector is equals to mass into E. Okay? Mg type. So this E here is the gravitational field intensity. Okay? Now this is the relation number one. Okay? Now if we displace the particle, from R to R plus dr, this length is R plus dr. A से B तक की length है R. Then B से dr we have displaced this particle. So length from A to this point, let's say this point is C, is become R plus dr. So in displacing, when displacing point mass from R to R plus dr. So what kind of force will act? The conservative force will act, and it will act in the negative direction to it. Got it? So work done here we have a very small work we will have because the displacement is very small. So it will be given by F vector dot dr vector. Okay? F vector we already know. What is this? So dw is equals to, put the value of F, it is m into E vector dot dr vector. Now, as we know that, or this would come in the integrational form. Okay. So we know that this work done in conservative field, because this field is conservative. Gravitational field is conservative. So in conservative field, या conservative force field, the work done, or the work done is equals to the, or we can say the potential energy, change in potential energy is defined as the negative of work done by conservative force. So this relation we are going to use here. This force is acted on this particle small m by this conservative field. So this force is also conservative, which means we are in a field of conservative field. Okay? We are in a conservative field. So all the forces acting on this particle m are conservative. So this work done is nothing but the work done by a conservative force. So if I want to replace this dw with delta u, so what the expression should be like? It will become minus of du equals to integration me dot dr, or you can say that du is equals to minus of mei e dot dr. Any problem in that? Okay. So what you can do now, on dividing by small m on both the side. So what do we have? We have du by m, and this m is a constant, so we can take in it out, and we are dividing it by m, so this m will cancel out. So minus of e dot dr. This du by m is nothing but the potential difference according to the definition. The change in potential energy per unit mass is potential difference. So it will dv is equals to minus of integration e dot dr. This is the first relation in between gravitational field and the potential. So you can say that this dv, which is the change in gravitation potential, is negative, which means if you move in the direction of electric field, like at this point A, the potential is VA, and this point B, the potential is VB. So the change in potential, which is VB minus VA, VB minus VA is negative, which means VB is less than VA, or you can say that VA is greater than VB, which means that if we move in the direction of gravitational field, if we move in the direction of gravitational field, the potential will decrease. Okay, so this is very important statement. Okay, you should note this. If we move, let me change the color of the pen. So if we move in the direction of gravitational field, intensity, the potential will decrease. Okay, I hope you are clear with this. Okay, now move on to the next page. We have defined that And please note it down. This dv is equals to minus of integration of E dot dr. Okay. If I take the limit from infinity to a point r, and we have considered that at infinity, let me consider it here, potential at infinity is equals to 0. Okay. Now we would have a value of potential 0 to v, because at point r it is v. So v at r is equals to, you can say that if you open this, you will have minus of infinity to r e dot dr. Okay. So if you take this minus here, you can say that minus of v of r is equals to e dr. So if r vector is equals to xi cap plus yj cap plus zk cap, for that you can also say, for this definition, this e vector is equals to minus of v at r divided by, just a second, you can define it as del v by del r. Okay, from here to here, it is the change of integration to differentiation. Okay na? So this term you have to understand, that changing from integration to differentiation would result in this. Okay na? Not vector. And if r is vector is equals to xi cap, yj cap, zk cap, so you can define it from now, because it is a partial differentiation. It is the partial differentiation. Which means if del by del x is written, if del by del x is written and you have expression of x square plus y square, so you will treat y square as constant. Only the x square will be treated as variable. Okay. So here if r vector is xi cap, yj cap and zk cap, so you can define ex, the x component of electric field intensity is minus of del by del x v, ey as del by del x, del by del y v, and ez has minus of del v by del z. So this thing you have to remember. These are the potential gradients. This del v by del z, del v by del x, del v by del y are defined as the potential gradient. Potential gradient. Okay. So I hope you are clear with this. This is the numerical we are going to solve in the next class. Or let's just we discuss it in this class only. Okay, to try to solve it based on the data that I have told you. The gravitational field intensity due to a mass distribution is k by x square I cap. Assuming the potential to be 0 at infinity, find the potential at x is equals to a. So we know that that is given to us v infinity is equals to 0. We know that dv is equals to del. So in general, we define the differentiation d by dx. ठीक है? When the difference, this is the absolute differentiation. Okay? But I have already told you that this is not the absolute differentiation. This is the partial differentiation. Partial differentiation means we cannot use the same term d. So we have used another mathematical operator which is del. Okay? So del is nothing special. Del is the name of this operator. Okay? And another thing, that del v by del x, I have defined you as the potential gradient. When anything, any physical quantity like distance, if it is changing with respect to time, so we would define it as rate. Okay? But if anything, like this is the river flowing, and if I move from here to here, my velocity will change. My velocity will change in crossing the river. So whenever a physical quantity change will be observed with respect to a length, this x is nothing but a distance, a length. So that quantity is not called rate. It is called a gradient then. Okay? So it is a gradient. Got it? Whenever we see the change of any physical quantity with respect to the length, with respect to width, with respect to distance itself, that term is called as gradient. But whenever we see the change with respect to time, it is said to be a rate of change. Okay? You will also see this in the next chapter in fluid mechanics. We will define a term pressure gradient. So the pressure changing per unit length, per unit height. है ना? As the height increases, the pressure will change. So we cannot say the rate of change of pressure. We will say the pressure gradient then. Okay. Now, here we know that dV is equals to minus of E dot dr. We have to calculate it. Now, here only the I cap is given. So we have to consider only the x component of it. So dV is equals to minus of E की value हमें given है k over x square dx. Okay. So from that we have to calculate the potential at x is equals to a. So infinity पे potential we know it is 0, and at a we have to calculate, let's say it is v. Okay. So we can say that v minus 0 here is equals to the integration of k by x square. And I have told you several times that integration of 1 by x square dx is nothing but minus of 1 by x plus c. C is the arbitrary constant. And it will take when indefinite integration is there. But here that integration that we are using is definite. So we do not have to put this arbitrary constant. So minus of this will become 1 by x infinity to minus of 1 by x infinity to a. So v is equals to minus 1 upon a minus plus 1 upon infinity. 1 upon infinity will become 0. So what do we have? We have v is equals to 1 by a. So we have miss k here, na? K is also here. So it will become k by a. Got it? So if anyone has any kind of doubt till now, you can ask. If the question is not clear to you, you can ask whatever kind of doubt you have. Okay, Divyanshu, this question is to you. This question is clear to everyone. Okay. Only Divyanshu is responding. Some must be also. Okay. Okay, Patil, you got it. Very good, guys. Very good. Okay, so I understand that you have got this. So this is for now. The lecture is being over. Thank you so much for being attentive. Take care of yourself and keep studying. Bye bye.